Welcome to another video of Theory Busters, but before we get started, we would like to thank the 50 subscribers family. Keep supporting Theory Busters for more such amazing videos. Now back to the video. The term black hole was coined in 1969 by John Wheeler, but many years before, in 1783, John Michell had written a paper, in which he had pointed out that a star that was very sufficiently massive would have such a strong force of gravity, that even light could not escape, but that was understood only when light behaved as particles, not waves. But, after Einstein published his paper on general relativity in around 1915, which introduced the idea of cause of gravitational effects through space-time, it was clear how gravity would affect light. Also, it meant that, if such an object existed which was sufficiently massive, it could create a point of infinite density, which now is known as singularity. This would imply that nothing, not even light, could escape beyond a specific boundary of black hole, known as the event horizon. Now let's talk about the formation of a black hole. For this we need to know about Chandrasekhar's limit. It states that for only a certain mass of star, the star could turn into a black hole. The stars are luminous because they use nuclear fusion. Nuclear fusion in a star involves the fusing of two hydrogens to make a helium atom and release high amount of heat and light which we receive every day, but this hydrogen is limited in a star, so after using it for billions of years, the star starts to fall short of hydrogen, so it begins to use alternative sources like helium, carbon etc., but it is likely to end up falling short of these elements too. Basically, a star has two forces acting on it. Gravity, that tries to collapse the star, and fusion energy, that is used to keep gravity in control. But what will happen when the star falls short of all sources that it can use for fusion? After this, the star is not able to withstand the gravitational pull that acts towards its center, and then it collapses over itself. During this, the star blows of some part of it into space in a huge explosion. This is today known as supernova. Due to supernova, star releases elements formed into the space nearby which can form the basis for formation of a solar system. The mass of the remaining star that has collapsed over itself bends spacetime in a manner regulated by general relativity. However, this point in spacetime is considered to be of infinite density, and all known physics breaks at this point. If the star is massive enough, it may turn into a neutron star or a black hole. A neutron star has a very short radius of usually 30 kilometers. It is also very dense. They have a mass of 1.4 solar masses. They are so dense that a tablespoon of neutron star weighs more than 1 billion tons. Still, neutron stars are no competition for black holes. Black holes have a gravitational force so strong that even light can't escape it. There is a point of no return in the black holes, also known as event horizon. The gravity is so strong that if a person was to enter it, he would quite literally become a spaghetti. This process is also given the name as spaghettification. In spaghettification, the feet are closer to the black hole than the head, so the feet will experience more gravitational attraction than the head. So the body literally becomes as thin as a spaghetti. What lies beyond the event horizon is a complete mystery. The center of a black hole is a gravitational singularity. All the laws of physics break here. It is a one-dimensional point. It contains a huge mass in an infinitely small space. A typical stellar black hole has a mass of 3 to 10 solar masses. Even a small black hole, the size of an atom, has the mass of a mountain. Black holes are too vast of a topic to be covered in just one video. Many topics like Hawking radiation etc. are left, so we have decided to make a black hole series. If you enjoyed this video, don't forget to like, share and subscribe to Theory Busters.